With every discovery Cassini made, more questions emerged. One such mystery started with a deceptively simple query. How long is a day on Saturn? Despite thousands of years of observing Saturn in the sky, scientists didn't have a clear answer. Unlike rocky planets, where surface features can be tracked, Saturn's thick layers of clouds obscure any solid core. These clouds rotate at different speeds depending on latitude, making it impossible to pinpoint a clear rotation period using visual markers. And Saturn's rings? Though mesmerizing, they orbit at their own variable speeds, depending on proximity to the planet. Using ring motion as a clock doesn't help here either. Scientists turn to Saturn's magnetic field to try a different approach. Magnetic fields are typically tied to the planet's core and can act as a natural metronome. For Jupiter, this method worked perfectly. The planet's magnetic emissions revealed its true rotation. But Saturn's field is different, almost perfectly aligned with its axis, which makes measuring rotational variations extremely difficult. It was Cassini's final orbits, its grand finale, that gave scientists their best chance. As the probe dove between Saturn and its rings, it directly measured gravitational and magnetic field data with unprecedented precision. From this, researchers discovered another surprise. Saturn's core isn't a simple solid ball. It's a diffuse, fuzzy region, perhaps extending more than half the planet's radius, a mixture of rock, ice, and metallic hydrogen. This blurred boundary challenges long-held assumptions about gas giants and planetary formation. Cassini also helped revise the mass of Saturn's rings, revealing that they are lighter than expected. This supports the theory that they are geologically young, likely formed during the age of dinosaurs on Earth. And yet, the true length of a Saturn day? Still debated. Cassini brought us closer, but the final answer remains elusive. Cassini's instruments also peered into Saturn's seasonal shifts. Over 13 years, it observed summer in the southern hemisphere and winter in the north, then watched as seasons reversed. These long-term observations gave scientists their first real look at how a gas giant's climate changes over time. And the mission's reach extended beyond Saturn. By analyzing Titan's thick atmosphere and Enceladus's oceanic plumes, Cassini shifted the focus of astrobiology to these distant, icy worlds. The findings fundamentally changed NASA's priorities, helping inspire missions like Dragonfly, launching in the 2030s, which will send a rotorcraft to Titan to explore its surface. Proposed missions to Enceladus, with plans to orbit or land and directly sample material from its plumes. On Infinity Beyond, we look at Cassini not as a mission that ended, but as one that launched an era of discovery. Its data will be mined for decades. Its images will inspire generations. Its questions will guide the next wave of exploration. What Cassini taught us most is this: even in the final moments of a mission, there is room for discovery. Even in death, there is legacy. Up next in Segment 6, the most beautiful images from Cassini, a visual tour through time.